That's the end of lesson number one. Now let's move to lesson number two, research design and research proposal. Research design is the overall plan or blueprint for conducting a study. The problem statement and research questions guide the choice of research design. It dictates how data will be gathered, analyzed, and ultimately what types of conclusions can be drawn from the research. The research design is the roadmap for answering your research questions. Kinds of research designs. Descriptive research. This aims to accurately portray the characteristics of a particular situation, event, or group. It focuses on describing what is without manipulating variables. Experimental research is designed to establish a cause and effect relationship between variables. It involves manipulating the independent variable to observe its effect on the dependent variable while controlling other factors. Descriptive research. Descriptive research aims to paint a detailed picture of a specific phenomenon or population for us in, let's say, population of a buyers or customers of a particular service. It focuses on accurately describing the characteristics, behaviors, or functions of the subject being studied, providing insights into what is and how it relates to its environment or community. The goal is to provide a clear and comprehensive overview. Survey and observation are two common data collection methods used in describing research to understand a phenomenon. Survey involves asking individuals about their experiences, attitudes, or behaviors related to the phenomenon. It's a structured way to gather self reported data from a sample of uh, from the population. Example: to understand customer satisfaction with a new product, a company might conduct a survey asking customers about their experiences, expectations, and likelihood of recommending the product to others. Survey method: the researcher prepares research instruments, sometimes we call it research questionnaire, that will answer the research questions. So these instruments are carefully prepared so that the data gathered from them is exactly what is needed. Observation involves directly watching and recording the behaviors or characteristics of individuals or situations related to the phenomenon. It's a method of gathering data through direct sensory experience. Example: to study consumer behavior in a retail store, a researcher might observe customers as they browse, interact with products, and make purchasing decisions, recording their movements, interactions, and expressions of interest. Experiment is a research method where one or more variables, independent, are manipulated to see their effect on another variable, dependent, allowing for cause and effect conclusions. So let's take a look at the variables. First, the independent variable. These are the variable that is intentionally changed or manipulated by the researcher. Example: in a study, the effect of exercise on weight loss, the amount of exercise, for example, 30 minutes per day or 60 minutes per day, or no exercise at all, is the independent variable. Dependent variable is the variable that is measured to see if it is affected by the changes in the independent variable. Example, in the exercise and weight loss study, the amount of weight lost would be the dependent variable. Experimental design is a detailed plan for conducting an experiment, outlining how participants are assigned to groups, how the independent variable is manipulated, and how the dependent variable is measured to test the cause and effect relationship. It includes procedures to minimize bias and control for extraneous variables. For example, a company wants to test the effectiveness of a new advertising campaign on product sales. They randomly divide customers into two groups. One group, they see the new advertising campaign, and they will be called the experimental group. The other group sees the old campaign or the control group. The independent variable is the type of advertising campaign, the new versus the old advertising campaign. And the dependent variable is the change in product sales. So we compare the sales performance of the two groups. The company can determine if the new ad campaign had a significant impact on the sales. A pre-test post-test experimental design is a type of experiment used to assess the impact of an intervention or treatment. It involves two groups, an experimental group, which receives the treatment, and a control group, which does not. Both groups are given a pretest at the beginning to measure the initial levels of the variable being studied. So this establishes a baseline for comparison. In a pretest post-test experimental design, after the initial pretest, the experimental group receives the treatment or intervention being studied and then takes a post test to measure any changes in the variable of interest. The control group does not receive the treatment but still takes the post test. This allows researchers to compare the results with the experimental group and determine if the treatment had a significant effect. The control group helps rule out other factors that might have influenced the result. A one shot case study is a research design where data is collected from a single group after they have experienced a treatment or event. There's no pretest or control group for comparison. The weakness of this type of design is that it's difficult to determine if the observed outcome was actually caused by the treatment or if it was due to other factors, since there is no baseline for comparison. For example, a company implements a new customer service training program. After the training, they survey the employees and find that 80% report feeling they are confident in handling customer complaints. However, without knowing how confident they were before the training, and without a group of employees who didn't receive the training, it's impossible to definitely say that the training caused the increased confidence. It could be due to other factors like a recent company wide morale boost. A one group pretest post design involves measuring a single group before and after a treatment or intervention. While it tracks changes within the group, the absence of a control group makes it difficult to definitely attribute changes to the treatment itself. It's a quasi experimental design. For example, a company wants to assess the impact of a new software on employee efficiency. So they measure employees' task completion time before the software is introduced. That's our pretest. After using the software for a month, They measure task completion time again, and this is our post test. If the post test shows a significant decrease in task completion time, it suggests the software might have improved efficiency. However, without control group that didn't use the software, the improvement could be due to other factors like increased employee experience or seasonal changes in the workload. Example of correlational research. A marketing analyst notices that there is an increase in sales during the months of November and December. Correlational research could be used to investigate the relationship between these months and increased shopping activity. While the research may reveal a pattern, it doesn't necessarily mean that those months cause frenzied shopping sprees. Other factors like the holidays could be influencing the increase in sales. Another example could be a business investigating the relationship between employee satisfaction and customer loyalty in a retail setting. They may find a correlation between the two, but cannot definitely claim employee satisfaction causes customer loyalty. Correlational research measures the strength and direction of the relationship or covariance between variables. It quantifies how much two variables tend to change together. The goal is to determine the extent to which changes in one variable are associated with changes in another, indicating the degree of their relationship. Correlational research is non experimental. And in choosing the research design, remember that the correlation is only valid up to the point when and where the data were gathered. A quasi-experimental research involves manipulating an independent variable to observe its effect on a dependent variable, but unlike true experiments, participants are not randomly assigned to groups. This lack of random assignment means that the groups may not be equivalent at the start of the study, which can introduce confounding variables and make it more difficult to establish a clear cause and effect relationship. For example, a company wants to test the effectiveness of a new marketing strategy aimed to boosting sales. Due to the existing customer base and the challenge of randomly assigning customers to different marketing approaches, a controlled experiment may not be feasible. Instead, the company implements the new strategy for one group of customers while maintaining the existing strategy for another group. Both groups are selected based on similar demographics and purchase history to reduce selection bias. Pre implementation data, like sales records, can serve as the baseline, and post implementation data can be collected to assess the strategy's impact. In this scenario, the independent variable is the new marketing strategy, and the dependent variable is sales revenue. Because customers were not randomly assigned to groups, this is a quasi experimental design. While the study can provide insights into the effectiveness of the marketing strategy, it cannot definitively establish a causal relationship due to the potential for confounding variables. A non equivalent groups design is a type of study where you compare different groups of participants, but these groups weren't formed through random assignment. This means the groups are likely different from each other in ways beyond just the treatment being studied, making it harder to draw firm conclusions about cause and effect. Because the groups aren't equivalent to begin with, Any differences you observe after the treatment could be due to pre existing differences rather than the treatment itself. A company wants to test the impact of a new training program on its sales team's closing skills. They administer a sales skills assessment test to the team, which will be our pretest, and then the sales team undergoes the new training program. After the training, they administer the same sales skills assessment test to the team once again, and this will be our post test. The company then analyzes the results. If the average scores on the post test are significantly higher than the average scores on the pre test, it suggests that the training program may have improved the sales team's closing skills. However, without a control group, it's difficult to rule out other potential factors that could have influenced the results, such as the general work experience or even the market trends. An interrupted time series or ITS design involves taking multiple measurements of a variable at regular intervals over time, before and after a specific event or intervention. We call it the interruption. By analyzing the patterns in data before and after the interruption, researchers can assess the impact of the event. Consistent data collection is crucial for a valid ITS study design. Combination designs, often called pre-test post-test control group designs, involve two groups, a treatment or experimental group and a control group. Both groups take a pre-test and post-test. Only the treatment group receives the intervention. The research focuses on comparing the post-test scores of the two groups to see if the treatment group performed significantly better than the control group, indicating that the treatment's uh, uh, level or extent of effectiveness. This design helps control for confounding variables and provides stronger evidence of a causal relationship. Now let's go to writing a research proposal. Your research proposal is composed of the first chapter of the research paper. It is composed of the following sections: 1. Background of the study. 2. Statement of the problem. 3. Hypotheses. 4. Theoretical framework. 5. Research paradigm. 6. Significance of the study. 7. The limitations of the study. And 8. Definition of terms. And that's it for our lesson number 2.